Bismillahirrahmanirrahim. This video is about Thevenin's equivalent circuit with dependent source, and here we'll be discussing example 10.9. Now, any circuit with a diamond-shaped source is the dependent source, and here you can see that this is depending on current I0, is 0.5 times I0, where I0 is this current here. Now, if while we try to find Thevenin's equivalent circuit, Thevenin will be calculated in the normal manner. So we see in the example, but Thevenin will be calculated by deactivating the independent source and then connecting a voltage source or a current source at the output, and then finding V out and I out, or V test, I test, which will give us the impedance. Now, this is the circuit that we have to solve. First of all, we redraw it in a simplified manner with the help of these boxes. It looks slightly neat. And also we mark the polarities depending on the currents. Now, keep in mind that in question, this current was not marked. This is marked. But since any current flowing through this will only pass through this, and this current is 0.5 I0, therefore we have written 0.5 I0 here also. We have also marked the output as with the name Thevenin, and these two nodes 1 and 2. Now, first of all, to find Thevenin, we have to find the current. And so current we can find by the KCL method at this node. And you can see 15 ampere is entering and I naught leaving and 0.5 I naught leaving. So 15 is equal to I naught plus 0.5 I naught. And from here we can calculate I naught to be 10 ampere. And now to find Thevenin, we have to solve this loop by the KVL equation. And we start writing from one corner. From here, negative sign. So it will be negative I naught 2 minus J4. Then positive 0.5 I naught 4 plus J3. And then Thevenin. So plugging in the value of current in this equation, Thevenin will be minus J55, which can be written as 55 angle 90. So let me show you with the help of a calculator how easily you can do it. Make sure that your calculator is in complex mode. So press mode and 2 complex. Now it is in complex mode. Now I will directly enter all these values. So 10 bracket 2 minus J4, 2 minus 4I, we write I for J, and then minus this 0.5 into 10 will make 5, so minus 5 bracket 4 plus J3, so 4 plus 3I bracket close, equal sign, it giving answer is minus 55I, that means minus 55J. And J is written in terms of angle as 90 degree. So minus J will be minus 90 degrees. So this is the answer for Thevenin. Now we'll find Thevenin. And we have to follow these. First of all, the first is to deactivate all independent sources. So this is our independent source. We deactivate. And the current source is deactivated by opening it. And the voltage source is deactivated by closing it or shorting it. So here we'll open this source. So this is the circuit left. And then the next step is to apply a test voltage or a test current source. Generally 1 ampere current source or 1 volt source is used. So let's connect that. We are connecting 1 ampere current source. This is our test source. And the voltage here, which was V Thevenin, we are naming it as V source. Okay, now with this we can find the impedance if we know V over I. That means if you know Vs over Is. Is already known, so all we have to do is find Vs from this circuit. Now we write the KCL at this node. This is the current entering now, 1 ampere, and these two are the current leaving, I0 and 0.5 I0. And from here, we write the KVL equation for this from here. So it is minus Vs plus I0 into these two. And from here, we putting the value of I0 in this, we find Vs to be 2 over 3, 6 minus j. So Vs found, Z Thevenin can now be found by Vs over Is. Vs is this value here, Is is 1 ampere. So this is Z Thevenin. And so our equivalent circuit can be drawn like this, V Thevenin and Z Thevenin. So I hope you have been able to follow this. Please let me know through your comments. Thank you.